Okay, now let's take a look at another group of special angles. The angles 30 degrees, 45 degrees, and 60 degrees are often referred to as special angles. We're going to look at how the values of these trigonometric functions can be computed using right triangles. So let's first take a look at 45-degree angles. So what we're going to do is we're going to create our 45-degree angle, and when I create a triangle, that's what I kind of think is the best way to do this with right triangles. Notice if I have a right triangle, the one angle is 90, and if I split the other two angles evenly, I get a couple of 45s. Hopefully you recall from triangles in the past that this now makes what we call an isosceles triangle with two equal sides and two equal angles. And so I'm going to label those two equal sides with any length. I just happen to take a length of 1 unit. So you'll notice if you look at my triangle that I have 1 unit and 1 unit. And now I'm going to compute the third side using the Pythagorean theorem. So the third side is C. I always call the side opposite the right angle C. And so if I do that, I get C squared equals 1 squared plus 1 squared, which is 2. So C is the square root of 2. Technically, remember, plus or minus, but we're dealing with lengths on a triangle, and so it's going to be positive the square root of 2. Now if I use our old friend SOHCAHTOA, and I look for the sine value is the opposite over the hypotenuse, and so that would be sine of 45 degrees would then be 1 over the square root of 2. And hopefully you remember a little bit about rationalizing denominators. So 1 over the square root of 2, if I want to eliminate the square root of 2, or the square root symbol in the denominator, remember I multiply the numerator and denominator of the fraction by root 2, so I have 1 over root 2 equals multiplied by root 2 over 2, and if I clean that up, I get the square root of 2 over 2. And so the sine of 45 degrees is the square root of 2 over 2. Cosine of 45 degrees, similar idea. Remember, cosine is adjacent over hypotenuse. So if I look at my 45-degree angle and go adjacent would be 1. The hypotenuse is still root 2, so I get 1 over root 2. And if I rationalize as I did before, that gives me the square root of 2 over 2. Quick comment about rationalizing. With these special angles, you'll see I rationalize, but through much of these couple of chapters of the book, it won't be necessary to rationalize, and your textbook at times will not rationalize. And so you'll have to be able to determine when you need to or not, basically to check your answers with the answers in the back of the book. So the sine, again, of 45 degrees is root 2 over 2. Cosine of 45 degrees is root 2 over 2. Let's now take a look at 30 and 60-degree angles, and these we'll actually be able to do using a single triangle. So I'm going to create a right triangle that has a 30-degree angle and a 60-degree angle, and notice that does work out nicely because 30 plus 60 plus the right angle does give us 180 degrees. And so a fact that you might be aware of is always going to be in a 30-degree, 30, 60, 90 triangle, the side opposite the 30-degree angle is always half the length of the hypotenuse. So what I'm going to do this time is label the hypotenuse with a length of 2, and so the side opposite the 30-degree angle will be half the hypotenuse, so that's going to be 1. And then I'm going to use the Pythagorean theorem to get the third side. And so if I do that, c squared is a squared plus b squared. So 2 squared equals 1 squared plus b squared. And if I do the math out, I end up getting b is the square root of 3. So now I have my triangle. There's my 30, 60, 90 triangle. The side opposite the 30 is the 1. The hypotenuse is 2. And I've just learned that the third side is the square root of 3. So now using SOHCAHTOA, the sine of 30, remember sine is opposite over hypotenuse, so find my 30-degree angle. Opposite 30 is 1, the hypotenuse is 2. So the sine of 30 is 1/2. Cosine of 30 degrees is the adjacent over the hypotenuse, so adjacent to the 30-degree angle is the root 3. The hypotenuse is 2, so the cosine of 30 degrees is root 3 over 2. As I said before, I can also get the values of the sine and cosine for a 60-degree angle. And I can use the same triangle, except now I just use the 60-degree angle. So the sine, again using opposite over hypotenuse, opposite the 60, now is the root 3. And the hypotenuse is still root 2. So the sine of 60 degrees is root 3 over 2. Cosine of 60 degrees, adjacent over hypotenuse, so here's my 60. Adjacent to that is a 1, and the hypotenuse is 2. So the cosine of 60 is 1/2. These are important values, and so again, you need to commit the below values, the values in this table, to your memory for easy recall. And we're going to actually derive these a little bit more even later on in the chapter. So notice, here's my table. We just take a look here. In the table, 45 degrees, sine and cosine are both root 2 over 2. 30-degree angle, the cosine is root 3 over 2, the sine is 1/2. 60-degree angle, cosine is 1/2, sine is root 3 over 2. I don't know about you, but I have a hard time remembering, the 45s I remember pretty well, but I've always had a hard time with the 30 and the 60. I can remember 1/2 and I can remember root 3 over 2, but sometimes I can't remember which one goes where. So what I've decided to do is just remember one of them. And I don't know why, but the one I choose to remember is the cosine of 60 degrees. Cosine of 60 degrees is 1/2. So now what I know is the sine has to be root 3 over 2, and then I notice as well that the 30-degree sine and cosine are just the reverse of the 60 degree. So if the cosine of 60 is 1/2, that's the sine of 30. And so therefore the sine of 60 is root 3 over 2, and that's the cosine of 30. So I just choose to remember one of them because I can remember what the actual values are, but I just need to place one in the correct place, and then I can remember the rest of them.